another very important concept. Remember guys, the last time I drew a straight line, I took a point over here and I said that the angle of a straight line is 180 degrees. I explained the same thing with the help of axis. You remember this? Where I said this is 90, this is 90, this is 90 and this is 90, correct? Now, this is a common point. Say O. This is 90, this is 90, this is 90 and this is 90. When I add up these two, I get 180 degrees. When I add up these three, I get 270 degrees. When I add up all the circle, I get 360 degrees.
360 degrees.
Correct. So this is what the theorem says. It says the sum of all the angles at a particular point, however the line might be. Now here it was even. Everything was 90, 90, 90, 90. But if you look at this diagram on the right hand side, do we know what angle 1, angle 2, angle 3 and angle 4 are? Do we know what the actual measurements are?
No.
No. But what is the one thing that we know? That because all the angles at the central point, all of them are forming a circle. And the angle of the entire circle is always 360 degrees, right? You agree with me?
Yes, sir.
So, what is angle 1 plus angle 2 plus angle 3 plus angle 4? 360 degrees. Is this clear?
Yes, sir.
Now, what else can we derive from this particular diagram that we have in front of us? Now guys, if you ignore this part, okay, say we only have this line and we have this, correct? Can you tell me what angle 2 and angle 3 add up to?
80 degrees.
How much?
80 degrees, sir.
80.
180.
180 degrees.
Exactly, 180. Why do they add up to 180? What is the reason? Because this was a straight line. Both the angles are on a straight line. Irrespective of what angle 2 and angle 3 are. Angle 2 can be say 60, angle 3 can be 120, angle 2 can be 50, angle 3 can be 130. We do not know. Whatever the angles might be. But we know that when I add both of them, I am going to get 180 degrees. Are we very clear now?
Yes, sir.
Any doubt?
No, sir.
No, sir.
Perfect. Sure. Now, vertically opposite angles. Have you come across this concept? This is very interesting. Have you come across this anywhere?
Yes, sir.
What is that you've come across? Is there some particular statement or theorem that you've always heard?
Sir, I don't remember much.
Okay, who said yes?
Sir, me, Babya.
Yeah, tell me, Bhavya. What do you know about this vertically opposite? Whatever you know.
Sir?
Yeah.
Sir, I'm just thinking that the sum of all these four adjacent angles is 360 degrees.
4 adjacent. Okay. So what you're trying to tell me is this. You're telling me that we have this angle, we have this angle, we have this and we have this. If I add all these 4 angles, I'm going to get 360 degrees. Perfect. Very good. That is something that you applied from the previous concept, right? Now, what else is there in this? Jaldi, I'm giving you 5 seconds. If no one's speaking, then I'll start explaining. Someone said yes, that they have some idea about vertically opposite angles. What is it? That's what I want to know.
Sir, I said that I just came across that concept, but I don't remember much about it.
You don't remember. Okay, cool. No problem. Chalo. The theorem. Let's first see what the theorem says. Then let's see why it is such. The theorem says that vertically opposite angles are always equal to each other. Guys,
Yes, sir.
what is this? Is this building vertical or horizontal?
Vertical.
Exactly.
Vertical.
And what is this?
Horizontal.
Now when he says vertically opposite angles are equal, that means this angle is equal to the angle exactly opposite to it. That means if I if I say call the center O, I'm saying angle AOD is exactly equal to angle COB. Point number one. Why? Because they're vertically opposite. Alright? Another point. Angle AOC is exactly equal to angle DOB. That is these two angles. Clear?
Yes, sir. Sir,
Yes, sir.
Yes.
sir, so the angles A or C are horizontally opposite angles, is an horizontally opposite angle to DOB.
Okay. The reason is because the reason that you're saying that is because of the point of view from which you are viewing it. For example, I shift it like this. For example, I say ACBD. Now tell me about AOC and BOD. Now they become vertically opposite for you. Hello.
Yes.
I just move the diagram to in such a way that both of them are vertically opposite. It's just about how you are viewing it. Vertical means in a straight line, right opposite to each other. As simple as that. Are we very clear on this concept?
Yes, sir.
Yes, sir.
Angles are equal. Now, we're not here to learn that vertically opposite angles are equal. Can you guess or can you tell me why vertically opposite angles are equal? Remember that math, you always have to ask the question why. Why are vertically opposite angles equal?
Sir, because there are two straight angles.
Okay, so this is one straight angle, this is one straight angle, this is one straight angle. By that sense, one second. Yeah. So we have 1, 2, even this is a straight angle, even this is a straight angle. Right? But,
Yes, sir.
but let's see if there is another way of proving that vertically opposite angles are equal. Now,
Or this diagram also.
okay, pay attention. I am calling this angle 1. Okay, I am calling this angle 2. I'm calling this angle 3 and I'm calling this angle 4. Okay, now I write angle 1 plus angle 2. What is angle 1 plus angle 2, guys? Jaldi. If I add these two angles, what do I get?
180 degrees.
Perfect. Now I'm saying angle 2 plus angle 3. What is angle 2 plus angle 3, guys?
80 degrees.
180 degrees. Perfect.
Yes, sir.
This is just to understand it. This is just to prove it. Okay. Now, if I call this equation 1 and if I call this equation 2, can I equate both of them? Is the right hand side of both of them same?
Yes, sir.
Right. So what do I get? I get angle 1 plus angle 2 is equal to angle 2 plus angle 3. Correct?
Yes, sir.
Angle 2 gets cancelled. You remember even in simple
Yes,
equations, isolating it, moving it to the other side, the sign changes, why the sign changes, everything is clear. So what are we
Yes,
left
sir.
with? Angle 1 equal to angle 3.
Yes, sir.
Isn't that what we proved? Angle 1 equal to angle 3. Vertically opposite angles are equal.
Yes, sir.
Is the idea now very clear to you? Is the proof also very clear?
Yes, sir.
Similarly, if you take angle 2 and 3 and 3 and 4, you will get angle 2 equal to angle 4. As simple as that. 1 and 3 get cancelled.
Sir,
Cool? Yes?
then the angles will be 90 degrees.
Which angles?
1 and 3.
No, they can be anything. So look, think logically. Acute angle is something like this. It is something that is between 0 to 90 degrees. What is the right angle? What is the right angle exactly equal to 90 degrees? Now,
Yes, sir.
if you look at angle 1, it is in this shape, right?
Yes, sir.
Right? So what I just broke it down, AOD. Now, Just by looking at it, can you identify what kind of an angle it can be?
An obtuse angle.
Perfect. Why? Because by looking at it, you know that it looks like something that lies between 90 and 180 degrees. Therefore, it is obtuse. But now, if I talk about angle 2, guys, what kind of angle does angle 2 look like? Acute, right? Obtuse. What does it look like?
It looks like accurate.
AOC. What does AOC
Like
look like?
acute.
Acute. Why? You can see that if it is something like this, it is between 0 and 90 degrees. Correct?
Yes, sir.
Yes.
Right. So 2 and 4 look like acute angles. 1 and 3 look like obtuse angles. And we also know that angles of the straight line equal 180 degrees. Therefore, angle 1 plus angle 2 is 180, angle 2 plus angle 3 is 180, angle 3 plus 4 is 180, angle 1 plus 4 is also 180. Very clear?
Sir, I have a doubt.
Yes.
Sir, in angle AOD,
Okay.
can we say that it's an acute angle? If we see it as DOA, I mean like,
Angle AOD and DOA are the same thing.
no sir, not like that. I mean like, it's tilted equally on both sides. So, acute angle.
Pardon, can you come again? Your voice was breaking.
Sir, can you hear me now?
I can hear you. Tell me.
Sir, I'm asking that in angle AOD, both the sides are tilted equally towards 0 degrees and 180 degrees, right? So I should be call it only an obtuse angle.
Because if you look at a shape like this, what kind of an angle do you think this middle, my palms are forming? If you can look at my palms. If I just put something like this, what do you think this would form? If this is forming something less than 90 and this is forming exactly 90, what if I just do that? What is it forming? Isn't it forming something more than 90 and less than 180?
Yes, sir.
So, do you see any resemblance between this and this in terms of the angle that they are forming? Do both of them look similar?
Yes, sir.
Exactly. So what are they? If it looks like something more than 90 but less than 180 degrees, because 180 would form a straight line, that is, I have to make it sleep completely. It hasn't slept completely. What does it look like? An obtuse angle, right?
Obtuse.
Exactly. Are we clear?
Yes, sir.
Okay. Just by initially looking at the diagram itself, I can figure out that vertically opposite angles are equal. But we looked at what the proof was. Now, just by looking at this diagram, I see that there's a lot of symmetry. Everything looks really perfectly drawn. So I can figure out that this and this look equal, this and this might be equal. But we want to prove it and have it as a theorem. Because it's a theorem, we tried proving it. You don't have to sit proving it in the exam until it's asked. The main theorem is the vertically opposite angles are always equal to each other. Are we clear?
Yes, sir.